is suppose 2. Suppose I am searching for 10 link 2 degree of freedom, will it be possible or not? So, f is equal to 2 minus 3 into 10 minus 1 by 2. Okay. So, I am getting 1 minus, I am getting negative. So, this is not at all possible, didn't it? Okay. So, the equation which we have f is equal to 3 into n minus 1 minus 2j, this is valid as Grobler's criterion for the single degree of freedom plane mechanisms. Same thing, it is being called Kutzbach criterion. It is also called Kutzbach criterion. Now, we will search the number synthesis relations So, out of these so many pairs, if the linkages are with turning pairs, if the link is with turning pairs, we have specific equations. Degree of freedom is equal to n minus 2l plus 1 and p1, that means the number of pairs which are causing 1 degree of freedom. So, p1 equal to n plus l minus 1. These two equations are there. Whether these two equations are valid for a particular kinematic chain, we will check it now. So, this is the kinematic chain which we have. So, here we need to, this is the kinematic chain. So, one kinematic chain is given here. In this kinematic chain, we are able to observe some things just by directly seeing this is the ternary link, this is the ternary link, this is the ternary, this is ternary, and this is a binary link, this is binary link, this is binary link, and this is binary link, right. So, in this problem we need to search only whether the linkage is having degree of freedom, how much it will have, based on the equations f is equal to n minus 2l plus 1 and p1 is equal to n plus l minus 1. Whether these two equations will be valid for a particular kinematic chain or not. Because suppose you are abruptly joining one of the link to 5 link or 6 link or something. Suppose you are getting some problem in the 6 link 1 degree of freedom. Directly joining the two links abruptly in between any of the two joints. Suppose in this the number of links are 11 here. Suppose we are getting some problem in a particular area. So, I cannot add another link like this. Instead of this, I am adding some other link. So, number it will become 6, it will become 12. So, I cannot add directly or abruptly whatever I need wherever I need. So, there are some equations. Obeying these equations only, the enumeration has to be in a particular streamline. Otherwise, we are generating a lot of chains. Suppose I am taking a 4 bar. So, this 4 bar chain, suppose I want to make it 5 bar. So, 1, 2, 3, 4. Between 1 and 2, if I add, I am getting one choice. Between 2 and 3, if I add one chain, if I add 3 to 4, 3 and 4, if I add another binary link, what will happen? 1 and 4, if I add, what will happen? Suppose I am saying 5 link. So, let it be just an example. I am adding one link between 1 and 2. So, this is 1, new link, 2, 3, 4, 2, 3, 4. This is the new link, this is 5. Actually speaking, earlier we discussed this becomes 5 bar link, but this particular link it will become completely free. So, these type of particular links they are not at all useful as a kinematic chain. So, there are some methods based on these equations obeying whether we are able to generate these type of the kinematic chains or not, that will be discussed. So, here what they are asking the number of binary links. So, 1, 2, 3, 4, 4 binary links. The number of ternary links 1, 2, 3, 4 and the number of quaternary links. In this only binary and ternary are given, no quaternary link is given. In another diagram quaternary link is given. Okay. And the number of total links, the number of loops and number of joints or pairs and the number of degrees of freedom we need to calculate. Now, here we see the number of loops, how to identify the number of loops. So, here we see in this particular diagram, so we are taking the figure A, how many loops are there? 2, 5. So, we will write separately starting with the 2. 2 is attached to 5, 5 is attached to 3, 3 is attached to 2. So, this is one loop. So, 2, 5, 3, 2, it is one loop. And again this one 5 and 3, 6, 4, 8. So, this is one loop. So, mark it 1, 2, 3, 4, 4 loops are there. So, here the loop means an enclosed area where we are getting different links, it is being covered. So, this loop 2, 5, 3, 2, that means a triangular loop, but actually the triangle means it is a redundant one. So, we should not use this type of the particular kinematic chain. These type of chains where we are getting the redundancy, we are calling redundant chain. Redundant means we should not use. Okay. So, if you are abruptly using, we are getting some energy loss. Okay. So, we will calculate whether these kinematic chains abruptly created, they are following the rules or not. Now, we will check it. So, here number of binary links are given as 4, number of ternary links are 4 and quaternary are 0, total number of links are 8 links are there, numbers are being given and loops are 4 loops. So, this is 1, 2, 3, 4, 4 loops are being given and P1 equal to 11 and F is equal to 3 into n minus 1 minus 2 P1, it becomes minus 1. and again the degree of freedom will become minus. That means something is wrong. That is why these type of the structures we are calling with the name superstructure. Actually, structure means degree of freedom has to be 0. Degree of freedom is 0. That means if one of the link in the structure becomes free, then it becomes kinematic chain. So, out of your links like this and something is there, if one of the link is being moved, it is given some freedom, then it becomes kinematic chain. F is equal to 0, it will be converted to F is equal to 1. But here it is given F is equal to minus 1. Whenever any structure is becoming minus, so something is wrong. Wrong means the position or formation or enumeration or creation of the kinematic chain is having some internal error. That error is redundancy. See here 2, 5, 3, 2. So, it is a triangle. So, 2 is the link 2, 5, 3. If you are drawing a graph. So, this is a particular loop. Triangle means there is no movement. It is completely locked. Whenever a particular loop is locked, automatically it becomes redundant. That means redundancy means we are unable to observe any output over there, because if one of the link is grounded, here the link is grounded, if you are giving the moment to link number 5, any link if you are given the moment,